Welcome to Programming for Kids with Scratch 2. I'm Mike Lehman, and thanks for joining me. This series of half-hour shows uses Scratch to introduce computer programming to kids, about 5th grade and up, and curious adults too. You'll learn all about programming in Scratch in this series. It covers loop blocks, repeat, repeat until and forever, decision blocks including if and if else, procedure blocks, variables, lists, messages, events, clones, even microphone and video webcam input. I'll create many programs including games, storytelling, drawing pictures, and programs that demonstrate important programming concepts including objects, threads, and polling. This series is all about doing and shows the creation of all working programs from start to finish. Scratch is a great first programming language and can have children very quickly creating and presenting stories and creating fun animations, all while learning valuable critical thinking skills, problem-solving skills, and the fundamentals of programming without any of the confusing and detailed syntax. Scratch presents programming commands as single blocks that are easily snapped together to make programs with very little typing. Don't let the ease of Scratch fool you into thinking that there's little here. Scratch programs can do a lot of things. Very little math is needed to make fun programs, and I give the very few equations that I'll use in a handful of about 50 challenges. Scratch is free and freely available from the highly regarded university MIT. With your web browser, you can create, share, and save your Scratch programs if you want to. You can also look online at literally millions of shared Scratch programs, and if you like, you can join the Scratch community. You can just sit back and watch this show, or you can go to scratch.mit.edu, click on the Try It Out icon, and have fun learning how to program too. All of these video challenge lessons and more are available at my programmingforkids.info website and at my programmingforkids.info YouTube channel. The countdown timer at the bottom of the screen shows how long until a program is first run. This show number 17 uses lists to create funny and strange sentences and demonstrates the set tempo block to change how long notes are played. I'll get started. In this challenge, I try to show that using a list of items is easier than using many copied command blocks, especially as the number of items gets larger. For this example, I want the cat to create random sentences. I'll start with the beginning of the sentence, grammatically speaking the subject. For now, I want the sentence to start as 3 words. The word the, followed by a color, and then a noun, like cat or dog. For example, the brown dog, the yellow bird, or the green bug. I want the color and the noun to each be chosen randomly so different sentences can be made. First I'll make the code for the random color names without using a list. Then I'll implement it with a list and compare the 2 versions of code. I want to put the cat on a stage. I'll go to New Backdrop, scroll down, Stage 2. I'll go back to the cat's scripts. I'll get the cat on the stage instead of floating in the air. When a green flag is clicked, I always want the cat to go to this position, Events. Now when the green flag is clicked on, the cat will go to -8, -74, which is its current location. First I want the name of a random color. I'll go to Data and make a new variable. Make a variable. I'll call it color. For this sprite only. Okay, only the cat needs it. I'll move it under the cat on a stage. I'll use 6 colors for now. If number is 1, I want blue. If it's 2, it's green, and so on. I'll need a random number. I'll go to Operators, pick random. If I pick random 1 to 6, then that'll make numbers 1, 2, 3, 4, 5, or 6. I'll run it a few times. 3, 5, 5, 5, 6, 4, 3, 5. An interesting set of random numbers this time. I'll need if else, control, if else. If the random number is equal to 1, I want the color to be blue. Go to Operators, equal. If it's equal to 1, if the random number between 1 and 6 is equal to 1, Data, want to set color to blue. I can try this again for the next one. If it's equal to 2, and I want green. Now the code will get a random number. If it's 1, it's blue. If the random number is 2, it's green. I could do the same for the rest of the numbers. What's wrong with this code? The problem is that each color isn't getting an equal chance. It might be a little hard to understand, but to keep picking random numbers for each one isn't fair. Imagine I did this without a computer. Imagine I rolled a 6-sided die instead. If a 1 means I win, a 2 means you win, 3 means someone else wins, and so on. We would roll the die only one time. We wouldn't roll it once for me, and then if I lose, roll it again for you. And if you lose, roll it a 3rd time for the next person, and so on. We'd roll it only one time and use that number to choose one of the 6. I'll generate one random number for the choice. I'll create a new variable, call it random value. For this sprite only for the cat. Okay. Move it down. Now I'll set random value to the pick random number. Instead of using pick random number, I'll use random value. Generate the random number. If the random value is 1, set color to blue. Else, if the random value is 2, set it to green. Copy this. If random value is 3, if random value is 4, if it's 3, I'll use orange. If it's 4, I'll use red. Copy. If the random value is 5, I'll use gold. Else, must be 6, I'll use silver. Try this a few times. I'll click on the green flag. I got red, green, green again, silver, green, silver, gold. What if I want to add 10 colors? Lime, sienna, magenta, orchid, pink, aquamarine, cyan, carmine, fuchsia, goldenrod. The cascading if becomes harder and harder to work with, and you can imagine all of the names of colors. I'll make a list of colors. I'll get the commands out of the way. Uncheck the variables. And make a list called colors. Only for the cat. Okay. I'll bring the monitor over to the right. Add a color to it. Need 5 more. Duplicate. Copy 2 more. Copy 2 more. I've got 6. Now I'll copy all the names. Control C. Control V. 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 Control C. And Control V. I'll need to make sure the list is empty when it starts. Add the delete. Delete all colors, then add all the colors in. Click on the green flag. Got my 6 colors. To get an item from the list, I use item. To get a random item, I could use the pick random and have 6 be the length of the list. I'll get length of list, length of colors. If I click on this a few times, I get green, blue, green, gold, red. Get various colors. This works. Nice thing about using length of colors is if I add more colors to the list, length of colors will be correct and all the colors will be randomly chosen. I won't have to try to find any of this code if I had a 6 here and make it a 7 or an 8 or something. There's an easier way to get a random item from the list. I'll get rid of this and select random. Click on random item of colors. Silver, green, green, blue, orange. Works just as well as the other code. I could save this in the color variable, but this item block will work well by itself. I won't need the sets and the ifs here. Get rid of them. I have random colors. Now I want random nouns. I'll make a list called nouns. For this sprite only, okay. Sprite's colors look good. I'll get rid of them. Bring in nouns. I'll need the list of nouns. I'll add the delete. All. Add. I'm going to want 8. Copy. Copy. This will copy 4 and give me 8. I'll put the nouns in now. Cat, bug, dog, rat, hot dog, TV, airplane, and giant. I'll see if this works. Click on the green flag. Nouns look good. Move it. I'll look at some random nouns. Random. Click on it a few times. Airplane, cat, airplane, hot dog, giant. Now I can display the subject phrase when the cat is clicked on. I'll remove nouns from the stage. Go to Events. When this sprite is clicked on, I'll go to Looks. Say, I'll need a couple joins. Operator, join, join. I can say the, pick item of colors. I'll move this over. Pick random item of nouns. Will this display the phrase correctly? I'll try it. Click on the cat. The gold bug, but it's all smashed together. There are many ways to add more spaces, including adding more joins, but I'll use the approach of adding a space in front of each of the words in the list. I'll add a space in front of blue, space, space, and the nouns. Now they all have a space in front of them. I'll click on the green flag. The lists have been reinitialized with the spaces. I'll click on the cat. I get the red dog, the red airplane, the gold giant, the red bug, the blue rat. Now to make interesting sentences, I'll go to my diagram and show the structure of the sentence. The sentence structure that I want to use will begin with the, followed by adjective, color, and noun, a verb part, and an indirect object part. For example, the sleepy green giant tripped over the school. Period. I'll have words coming from lists. I'll have lists holding adjectives and colors, nouns, verb parts, and indirect object parts. Notice that there are 7 parts. The is 1, 2, 3, 4, 5, 6, and 7. I'll need all 7 parts to make a sentence. I'll go back to Scratch and create my list of adjectives. I'll go to Data, make a list, adjectives, for this sprite only. Okay. Move it over. I'm running out of room when the green flag is clicked here, so I'll get another one. Events, when green flag clicked, back to data, delete, all adjectives to be sure I got an empty list, add, I got 7 adjectives, duplicate, 2, 4, 3 more, 7, I'll add space sleepy, space hungry, space thirsty, space sneezy. Starting to sound like Snow White and the Seven Dwarfs. Curious, thoughtful, gentle. I'll have a space in front so they'll join nicely. I can initialize the adjectives list. I'll click on this. And I have the list. List looks good. I'll remove it from the stage. Next, I want the verb parts list. Make a list. Verb parts. For this sprite only, okay. Move it over. Delete all. Add. I'll need 6 more. Duplicate. 2. 4. I need 3 more. 7. Laughed at with a space at the beginning. Space barked at. Space sat on. Space tripped over. Jumped over. Tickled. And surprised. I'll click on this. Got my 7 there. I'll remove it from the stage. Now I'm ready for my last list, indirect object parts. Make a list. Indirect object parts. For this sprite only, okay. Bring it over. I'll get one more when green flag clicked. Events. When a green flag is clicked, back to data. Delete all. All. Add. I've got 5. I'll need 4 more. 2, 4, 5. Space the sky. Space the forest. Space the lake. Space the moon. And space the school. Click on it. And the list is initialized. I'll remove it from the stage. Now I have all my lists ready. I'll talk about this in a future challenge. Having multiple green flags in a sprite or across multiple sprites isn't a problem. Only the coordinating of initializing things can be. It's not going to be an issue on this challenge. Some of the blocks are a little clipped on the display. I could zoom back and zoom back in, but it gets a little hard to read. I'll leave it like this. Now I have all the sentence parts, so I only need to join the parts together. I need 6 joins to put 7 parts together in one say statement. That's getting too long and complicated. Instead, I'll build the sentence with a string variable. I want to make a new variable called sentence. Make a variable, sentence. For this sprite only. Okay. I'll remove it from the stage. I'm going to be displaying the sentence anyway. I can initialize sentence with the beginning. I'll get set sentence. When the sprite is clicked on, I'll move the join in. I want to have the adjective before the colors and the nouns. So I'll move this off. Move colors to the end. Duplicate. Get adjectives. Now I have the adjectives with a space at the beginning. Space colors. I'll duplicate. Put sentence in. So for the next part, I'll join the adjective colors with, don't need adjectives or colors. I'll get nouns. Then I want verb parts. I'll change it first. verb parts. Now I can see nouns and verb parts. Copy this one more time. I want the say on there. Scroll over. After verb parts, I want the indirect object parts. I can get rid of the ending item. Get rid of this item. I want the period at the end of the sentence. Set sentence to the adjective, colors. Then I'll join to that noun, verb part. Then I'll join to that indirect object parts and a period. Should be right. I want to say the sentence. Sentence. I'll make it a little bit longer. I'll make it 3 seconds. Should be ready to run. I'll reinitialize the program. I'll stop it first. Click on the green flag. Now I'll look at a message from the cat. The curious blue giant jumped over the school. The gentle blue airplane barked at the lake. The thoughtful orange airplane sat on the sky. The gentle gold giant tripped over the forest. The hungry orange cat laughed at the moon. The thirsty orange giant sat on the school. That can't be good. The sneezy blue bug surprised the school. That would surprise the school. The sleepy orange giant sat on the lake. I guess the lake was frozen, and quite frozen. The sneezy gold giant tripped over the moon. That is quite a feat. Sorry about that one. The hungry silver hot dog barked at the lake. And the thoughtful blue dog barked at the forest. Some of the sentences were believable, some were silly, and some didn't make any sense. Creating meaningful sentences requires a lot more than a valid sentence structure. It requires an in-depth knowledge of the meaning of each of the words. Now you can see why automated phone answering systems that businesses use have a very limited vocabulary, and when they don't understand you, they forward you to a person. Also keep in mind that there are automated answering systems in Japanese, Spanish, Russian, Chinese, and the list goes on. Using machines to recognize and understand these natural or ordinary languages is a huge topic in artificial intelligence, dating back over half a century. You can start playing with artificial intelligence now. Change this program by adding or changing lists to make new and funny sentences, or create your own sentence structure. But most importantly, play with this example and get comfortable with lists and using join. This example program can be a lot of fun. This is a Nano challenge, and this is Nano. Nano is 1 billionth. That's 10 to the minus 9. 9 zeros. A nano is a small number, so this is a short challenge. The set tempo block specifies the speed at which Scratch plays notes and drums. The tempo is in beats per minute. A higher number means more beats per minute, so the notes are played faster. Set tempo 60 is 1 beat per second. 60 beats into 60 seconds is 1 beat per second. Set tempo 120 is 2 beats per second. 120 beats into 60 seconds is 2 beats per second. I'll show this in Scratch now. It's a Nano challenge, so I'll get Nano. Delete the cat with a right click. New sprite. Fantasy. Double click on Nano. I'll create a procedure block to play the notes. It'll be given the beats per minute value, so it can easily play the same notes with 2 different beats per minute values. I'll go to More Blocks, make a block, play notes, have one option, a number, and that'll be BPM for beats per minute. Okay. I'll move the definition down. I'll want to call this twice. Once, change the 1 to a 60 for 60 beats per minute. A second time for 120 beats per minute. I'll want to do this when a green flag is clicked. I'll first set the tempo before playing the notes. Sound, set tempo, set it to beats per minute. Now to play a note, play note. I'll use 1 beat instead of half a beat. I want to play the note 4 times. Control, repeat. Change the 10 to a 4. And I'll have Nano say what the beats per minute value is. Go to Looks, say, beats per minute. Now when the green flag is clicked, Play Notes is called with 60 beats per minute. The tempo is set to 60, Nano will say 60, and it'll play the note 4 times. When it's finished, Play Notes for 120 will be called, beats per minute will be 120, tempo will be set to 120, Nano will say 120, and the 4 notes will be played faster. The program's ready to run. I'll click on the green flag. 1, 2, 3, 4, 1, 2, 3, 4, and it's finished. I'll stop the program. Defining my own procedure block to set the tempo and play the notes made it very easy to play them twice without copying all the sound blocks. Playing the notes at 120 beats per minute was just another call to the Play Notes block. I can easily add a third block or many more. I'll duplicate, change 120 to 180, 60 is 1 beat per second, 120 is 2 beats per second, 180 is 3 beats per second. The program's ready to run. Click on the green flag. 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Much faster. Defining useful procedure blocks can be very powerful. I'm finished with this Nano challenge. I encourage you to play with the program and get comfortable with setting the tempo and using procedure blocks. But above all, have fun with the program. I'm glad you could join me. You can review these and all of my challenges at my programmingforkids.info website and on my programmingforkids.info YouTube channel. I encourage you to try the things you've just learned and explore the extra challenges I've suggested. I hope you can join me for the other shows. Until next time, have fun being creative.